All right, guys, today we're going to learn probably one of the most important lessons that is going to set the foundation for the rest of our study in trigonometry for most of the rest of the year. And that is the relationship between different sides of a right triangle. And so let's just start and let's just say we have this triangle. It's a right triangle. And we have an angle, 90-degree angle there. And we have, let's say we'll have an angle called theta right there. First thing we want to learn is we want to understand what the names of the sides are called in relation to this angle theta. So the angle, the side that you can draw an arrow across from, if that is theta, this is called the opposite side. So once again, the opposite side is the side that you can draw an arrow from the angle, whatever angle that you are looking at in the right triangle, across. All right, now the side that you cannot draw an arrow to, or the side that is next to the angle theta, we're going to call that the adjacent side. So that is your adjacent side. And the side across from the 90-degree angle, as you probably already know, is called the hypotenuse. So we would just put HYP right there. All right? And so these are the sides, the relationship to the angle theta. Now obviously if the angle theta is up here, all right, in the upper corner, well then the sides would change. The opposite side would be the bottom side, and the adjacent side would be the right side, or whatnot. All right, so the next thing we want to focus on is understanding what these 6 trig functions are, what they mean. So we have sine, and you're probably very familiar with 3 of them. We have sine of theta, we have cosine of theta, and we have tangent of theta. Now, the sine of theta, let's just talk about what that is. The sine of any angle, theta, all that has to do is with the ratio between the opposite side and the hypotenuse. That's all it is. So, how do you find the sine of any angle? If you have a right triangle and you know the 3 sides of the triangle, all you do is divide the opposite side length by the hypotenuse, and that will give you the sine of the angle. All right? Cosine, and that is going to be your adjacent side divided by your hypotenuse. And then finally, tangent is going to be the opposite side divided by your adjacent side. And so sometimes you will probably be very familiar with ka and toa. Very easy way for you to remember that the sine is the opposite over the hypotenuse. So that's that one. The cosine is the adjacent over the hypotenuse, and the tangent is the opposite over the adjacent. All right? So those are the main 3. Now, each one of these has, we'll call it a brother or a sister. All right? So the sine, its flip is going to be called something new. It's going to be new for you. It's called the cosecant. All right? So the cosecant, it's a new word for you, is going to be the reciprocal of the sine. So this is going to be the hypotenuse over the opposite. And then you have the secant, and that's going to be the reciprocal of the cosine. So hypotenuse, all this is going to make a lot more sense in a little bit, over the adjacent. And this one's pretty easy to remember, the cotangent. Cotangent. And that is going to be the adjacent side over the opposite side. Now, the way I memorize these is that each pair has the word co in it. So notice that. You have sine And which one is the reciprocal of the sine? The cosecant. Notice, you have one co in that pair. You have sine and cosecant. All right, what's the next pair? You have cosine. And which one is the flip of the cosine? Just the secant. Okay, now look at that pair. What do you have? You have a cosine and a secant, only one co. And then the last one is simply going to be, we'll put that over here, that's going to be your tangent. And the one that is the reciprocal of the tangent is the cotangent. Once again, notice that there's only one co in each pair. So that's going to be a start, and then we're going to go ahead and jump into examples 1 and 2 and 3 on the next slide. All right, what I'm going to show you here is probably the most important thing that you are going to need to learn for the rest of the year and for calculus next year. So please pay very close attention to this. This is extremely important. Okay, all of trigonometry is basically developed and built on two very special right triangles. So the first is a 30, 60, 90 triangle. So we'll put that over here. So, matter of fact, we'll do the first one first. We'll do 45, 45, 90. So this is 45 degrees, 45 degrees. The only reason why I did this one first is because the way I drew it, the sides look the same. And that makes sense because in geometry, you learned that if these angles are equal, right, then the sides across them should also be equal. So the ratios of the 45, 45, 90 triangle is going to be 1, 1, square root of 2. All right, 1, 1, square root of 2. That is important to memorize, extremely important to memorize, all right? So the sides across from the 45s are going to have a length of 1, and the side across from the 90, which is called the hypotenuse, is going to have a length of root 2. All right, so now let's do the second triangle, and this is going to be a 30, 60, 90 triangle. So let's just say we'll make that one a little bit more like that. So we'll call that the 30-degree angle. We'll say this is 60, and this is 90. Okay, now across from the 30 at all times, no matter where the 30 is, if the 30 is in the bottom left or the 30 is in the top right, it doesn't matter. Across from 30 is always going to be the number 1. Across from 60 is always going to be root 3. Across from 90 is going to be 2. All right, now the way you can memorize this is very simple to memorize. Across from the smallest angle is going to be the smallest side. That makes sense. Just think about that and try to convince yourself of that. If you have a very small angle, like 10 degrees or 12 degrees, well, think about it. The side across from that angle is going to be very small. If you have a very big angle, then the side across that's going to be big. Now, root 3 is about 1.73. So do you notice that the side across from 60 is bigger than 30, but it is less than 90? Well, 1.73 or root 3 is bigger than 1, but less than 2. And 90 is the biggest angle, so across from 90 is the biggest side too. All right? So these are very important to memorize because in the next unit, or should I say next section 4.3, we're going to build the entire unit circle on these two triangles. But for right now, we are going to see if we can figure out the 6 trig functions of 30 degrees. So this is going to be, I believe it's example 2 on your notes. Example 2. And it says find the 6 trig functions. Well, let's just start. We have sine of 30 degrees. And as we just said in the last slide, the sine, so katoa, is equal to the opposite over the hypotenuse. Opposite is going to be 1, and the hypotenuse is going to be 2. All right, we're done with that one. Cosine And I would encourage you right now to stop the video and see if you can do all 6 of these and check your work. All right, cosine of 30. So ka is going to be adjacent over hypotenuse. Okay, by the way, this one is opposite. So, and then this is ka. So adjacent over hypotenuse is going to end up being root 3 over 2. And then we have tangent. Tangent, SOHCAHTOA, opposite over adjacent. So opposite is going to be opposite of 30 is going to be 1. And actually, let me do that in blue. So that's going to be 1. And the adjacent is going to be root 3. Now, just to let you know, a lot of times we don't leave the radical on the bottom of fractions. And so what you're going to see more frequently is it written after you multiply the top and bottom by root 3. So notice if you multiply the top and bottom by root 3, notice what you get. You end up getting root 3 over, well, we know that a root times a root just gives you the root, the number underneath the root, so it's just 3. So that's probably what you're going to see more than likely. All right, or should I say more often. Now we need to get the other 6. So remember, sine, opposite over hypotenuse, and then we have cosecant, which we write as CSC, cosecant of 30. And that's just going to be the reciprocal of the sine, so that's going to be 2 over 1, or just 2. And then the cosine, well, the flip of the cosine is going to be the secant. We write that as SEC, secant of 30 degrees. And that's just going to be 2 over the square root of 3. Once again, we normally don't leave the root on the bottom. So with a little bit of work, you'll see that's going to end up being 2 root 3 over 3. And then the last one is going to be your cotangent. And run out of space, I'll do that over here. Cotangent of 30 degrees. Now, you may be thinking, okay, maybe I need to flip this one root 3 over 3. I would recommend it's much easier to flip that one. Remember, before it was root 3 over 3, it was 1 over root 3, right? So it'd be much easier to flip that one to get the cotangent than to be trying to flip the root 3 over 3. So if you flip 1 over root 3, that just gives you root 3 over 1, or just root 3. And those are the 6 trig functions for 30 degrees. For the sake of time, I'm going to skip the 6 trig functions for 45 because I think you can do that on your own. You've got the triangle there, and we're going to go on to the next example. All right, example 3. This is a pretty simple example here. It says, let theta be an acute angle such that the sine of theta is equal to 5 over 6. All right, so essentially, once again, what does that mean? Well, it means that the sine of some angle theta that we don't know is equal to 5 over 6. Now, earlier we said the sine of any angle is equal to the opposite side divided by the hypotenuse. So what we can do is we can draw a triangle, and we can, oops, let me just go ahead and put that there. So this is 90, and we'll put theta down here. Doesn't really matter where you put it, but we'll put theta right there. And we are going to make the opposite side 5, and the hypotenuse is going to be 6. Now, in order to do these 6 trig functions, you need to know all 3 sides of a triangle. And once again, it has to be a right triangle. So for right now, why don't we call this A? All right. So we're going to do the Pythagorean theorem to find A. So let's see here. We have A squared plus B squared, which is 25, equals C squared, which is 36. So you subtract 25, and A squared equals 11. So A equals the square root of 11. All right, so now I can go back and erase that, and I can go ahead and put in its place root 11. So, anytime you have two sides of a right triangle, you can always use the Pythagorean theorem to get the third side. So now I've got all three sides. Hey, this should be a real simple problem because I know SO katoa now. So cosine of theta is the adjacent over the hypotenuse. I'm going to keep writing these out so that you continue to memorize them. Adjacent, so cosine, adjacent over hypotenuse. So adjacent is going to be this guy right here, and the hypotenuse is going to be that right there. So adjacent is going to be root 11 over 6. All right, and then we have the tangent of theta. That's going to be the opposite, so TOA, opposite over adjacent. Opposite is going to be 5 over adjacent, which is root 11. And once again, when you multiply the top and bottom by root 11 to get the radical off of the bottom, if you need to do that on your own, please feel free to do so, but you're going to get 5 root 11 over 11. All right, we've got the three basic ones. Now we need to get the other ones. So, which one is the reciprocal of the sine? That is going to be the cosecant. Okay, so I'll do those in red. So cosecant of theta is going to be 6 over 5. And then the secant of theta, that's going to be 6 over root 11, which is just the flip or the reciprocal of the cosine, or 6 root 11 over 11. And then the cotangent, which is COT of theta, is simply going to be the flip of the tangent. Now once again, last thing you want to do is try to flip that guy. That looks really complicated. So don't flip him, flip him. 5 over root 11. You flip that, you're in business. So that's going to be root 11 over 5. And those are your 6 trig functions for this particular triangle. All right, this next example is also a pretty easy one. I think you guys will find this to be easy. You did this in geometry a few years ago. All right, you have a right triangle with a hypotenuse of 8, and it has a 37-degree angle. It doesn't matter where you put the 37. So I'm going to draw a right triangle. Of course, the 90 degrees is there. I can put 37 up top. I can put 37 down below. For right now, I'm just going to put 37 degrees right there. Okay, so that's 37 degrees. The hypotenuse is 8. So there's a hypotenuse. It says find the measures of the other two angles and the lengths of the other two sides. Well, if it's a right triangle, you know that one of the angles is 90, so that's pretty easy. And we also know that all three angles of a triangle, all the angles of a triangle must add up to 180 degrees. All right, so if this is 37, then this angle up top is going to be 53. So that's going to be 53 degrees. All right, so we've got all three angles. Now we just need to get the other two sides. So once again, we will call this side X, and we'll call that Y. You can call them whatever you want. All right, and so what you're going to say is, well, I'm going to take the sine of 37 degrees, and once again, remind yourself, the sine of any angle in a right triangle is equal to what? The opposite over the hypotenuse. So y over 8. All right, and you multiply both sides by 8, and the 8's are going to cancel, and you end up getting the side y equal to 4.81. And that is the side for y. All right, now, just to make sure you understand, you could have also chosen to use the 53-degree angle. I want to make sure you know that there's different ways to do this. You could have used the 53 angle to find y. However, if you were going to do that, what is the relationship between the letter y and the angle 53? Is it the opposite side? No, it's not. It's the adjacent. So you would have to say cosine of 53 is equal to the adjacent side of 53, which is y, over the hypotenuse, which is 8. And if you multiply both sides by 8, you will see that you end up getting the same answer. All right? So let's go ahead and get x. Now, some of you may be thinking, well, hey, since I already know that y is 4.81, and I already know that the hypotenuse is 8, can't I use the Pythagorean theorem to get the third side? Absolutely you can. But for practice, we're going to use trigonometry, and we're going to get the third side that way. All right? So what trig function, if you wanted to use 37 degrees, which trig function would you use? Well, let's look at it. X is the adjacent side to 37, so I'm going to use cosine. You could use tangent here. You could use sine. There's different things you could use. You may want to do that as an example. So I'm going to say cosine of 37 degrees is equal to the adjacent side, which is x, over the hypotenuse, which is 8. Once again, multiply by 8 on both sides. 8s are going to cancel, and you get x equals 6.39. All right, now, something that's very important here that I need to make sure that I mention. When you are dealing with any sort of trigonometry, you need to make sure your calculator is in the correct mode. In this problem, the angles are in degrees, so therefore your calculator needs to be in degrees. All right. For some problems, it's going to be in radians, and you just have to pay attention to that as we go along. It will become clear which mode your calculator needs to be in. Okay, this is example 5. And first thing you need to know how to do in these problems is draw the correct picture. All right, so it says here we want to find the height of a building. So it says from a point 340 feet away from the base of the Peachtree Center Plaza. So let's just say we have this big plaza right here. All right, that is your building. So we will say that is the Peachtree Center Plaza. All right, so that is your building. Now, notice what it says. You just have to read it pretty carefully, and you can get these problems pretty simply. From a point 340 feet away from the base of the building. So that means over there, 340. So that is going to be 340. Okay, the angle of elevation. Now, let's talk about that. The angle of elevation is nothing more than the angle from somebody that is standing on the ground looking up to an object that is on top of a building. That angle is going to be 65 degrees. So 65 degrees. Okay? And what are we looking for in this problem? We are looking for the height of the building. So we'll call that H. All right, so now you have to assess. This is your turn. You have to think, okay, what side do I have? If I'm going to use 65 as my angle, what side do I have? I have the adjacent side. What am I looking for? I'm looking for the height of the building. That is the what? Opposite side. So I'm looking for the opposite. I have the adjacent. Which trig function out of the 6 or out of the main 3 should I use? TOA, opposite and adjacent. So I need to use tangent. So I'm going to say tangent of 65 is equal to the opposite, which is H, over the adjacent, which is 340. And once again, you're going to multiply by 340 on both sides. And you get a height of 924 0.22 feet. And that is the answer to this problem. All right, example 6. We're almost done. We got this one and number 7. Find the following angle measures and give your answer, okay? Give your answer in degrees and radians. So make sure you read these questions carefully so that you are giving me the answers that we're asking you for. All right, cosecant, we'll just do letter A, and then I want you to stop the video and do B and C on your own and see if it matches with the answers that I get. All right, example A. It says that the cosecant of theta is equal to root 2. Now, anytime you're given a number that stands alone, you can always write that fraction over 1. You say, well, why would you want to do that? Well, that way I can see the ratio between two sides of a triangle. All right, so now we have to remember, okay, cosecant. And let me help you out here. This is going to be a lot of memorization for you, a lot of memorization. But you guys can do it, okay? Cosecant, that is going to be the flip of the sine. So sine is opposite over hypotenuse. So this is going to be the hypotenuse over the opposite. So you're going to draw a little triangle. And you're going to put theta right there. And then you're going to say, okay, hypotenuse over opposite. So my hypotenuse is root 2. So guess where root 2 goes? Right there. And where does 1 go? 1 goes right there because that is the opposite side. Okay? And you're looking at this triangle and you're remembering something that we did earlier in this video. You're saying, okay, which of the two main triangles that we have studied have sides with 1 and root 2? Oh, it's the 45, 45, 90 triangle, okay? So that automatically makes this side 1. So 1, 1, root 2. And now you must ask yourself, okay, then what should theta equal? Theta has to equal 45 because only in the 45, 45, 90 triangle do you have 1, 1, and root 2 as the ratios of the sides. So this angle right here is actually 45 degrees. So that's what theta is equal to for this first one, 45 degrees. All right, so once again, I want you to stop the video, and I want to see if you can work out B and C on your own, and then start the video again. All right, so letter B. Cosecant of theta is equal to 2 over root 3. So let's see what this says here. Cosecant of theta is equal to 2 over root 3. Well, once again, we just had this problem. Cosecant is the hypotenuse over the opposite. So once again, we're going to draw a triangle. Hopefully each time we're doing these, you're getting more and more comfortable. We're going to put theta down here. That's where I like to put it. You could put it up at the top, but I like to put it in the bottom. And once again, hypotenuse over opposite. So hypotenuse is 2. Well, that's going to go right there. And opposite, root 3, that's going to go right there. And you're looking at this triangle and you're saying, okay, which of the two main triangles that we studied earlier have a hypotenuse of 2 and a root 3 as one of the sides, and then the other side has to be 1. You're saying, oh, that's the 30, 60, 90 triangle. 30, 60, 90. Now you're asking yourself the question, in that triangle, in the 30, 60, 90 triangle, this is important, which angle is across from the side root 3? That's going to be 60. So theta equals 60 degrees. You say, well, how do you know that? Well, once again, let me repeat it. The side across from the biggest angle is going to be the biggest side. So 2, let me circle that. 2 is across from 90. Okay, so here's 90. Let me draw an angle arrow over there. That's going to be the biggest side, across from the biggest angle, 90. 1 is the smallest side, That's going to be across from 30 degrees. So then by default this is going to be 60, which is across from root 3 at all times. All right, let's do this third example. Secant of theta is equal to 2 over root 3. Secant, okay, that is going to be the reciprocal of the cosine. So this is the way I want you to be thinking. Cosine, ka, adjacent over hypotenuse. Oh, so this must be hypotenuse over adjacent. So now I'm going to draw the same triangle. This time I'm going to make my hypotenuse 2, okay? I'm going to make my adjacent side. So let's just say this angle is theta again. I'm going to make my adjacent side to be root 3. By default, that's going to be 1. And once again, we're back to that same 30, 60, 90 triangle. Which angle is across from 1 in this triangle? 30 degrees. So theta equals 30 degrees. Okay? Now, I forgot something very important. We got to go back and give all these angles in terms of radians. So we got to convert them. All right? So if you remember that from 4.1, that pi radians is equal to 180 degrees. Very important to memorize that. That's important. So we're going to convert each one of these angles into radians. So we'll do this 45 one first. So 45 degrees is equal to pi radians over, excuse me, not equal to, times. Let me do that, times, because you're multiplying by the conversion factor. So times pi radians over 180 degrees. Okay, degrees cancel, and you end up getting 45 pi over 180. Well, when you reduce that fraction, 45 over 180, you get 1/4. So this is going to be pi over 4, and you'll start to memorize these after a while. All right, let's go ahead and do 60 and 30. Why don't you stop the video and do 60 and 30. All right, so 60 is going to end up being pi over 3. And 30 is going to end up being pi over 6. You say, well, how do you get that so fast? Well, here's a little shortcut. What is pi? Pi is 180 degrees. So what is 180 divided by 3? 60. What is 180 divided by 6? 30. So pi over 6, pi over 3. All right? And we're going to do the last problem here in the next slide. All right, in this last example, example 7, we need to find the total area of the rectangular panel and then the total surface area of the entire rectangular prism. All right, so let's just see if we can figure this out. First and foremost, let's assess the situation. We've got a right-hand side, so let's just see how many sides we have. We've got a right side, we've got a left side, we've got a front side, we've got a back side, and we've got a bottom side. So we've got 5 sides. And what is surface area? Well, it's just the way it sounds. It is the total area of all the surfaces. We've got 5 different surfaces. All right, so we can actually get a couple of these things now. Let's just take a look at the back of this. This would be, that would be this back side there. Well, what shape is the back? The back is a rectangle. And so it's going to be length times width. So we'll just say the area of the back is going to be length of 12 times a height of 5, that's going to be 60. All right, so 60 feet. All right, so that is the area of the back. Now I want you to notice that the left side, which I'm going to draw there you go, the left side and the right side have the shape of a triangle. And what is the area of a triangle? The area of a triangle is going to be base times height divided by 2. Okay? So notice that we have the height of the triangle. That is 5. We do not have the base, but we do have an angle of 54. This is where trig comes in. So let's just say I make this triangle over here so that you can really see what we have. We have 5. We have 54 degrees, which is right there. All right, and notice what we need. We need the base of this triangle. If we can get the base, then we can get the area. So let's think about what we have. We have the opposite side. We're looking for the adjacent side, so tangent. So we're going to say tangent of 54 is equal to opposite, which is 5, over the adjacent, which is b. And notice this is the first example you've seen where the variable is on the bottom and the number is on the top. So we need to do 2 steps here. We need to multiply by b on both sides so that the b's cancel. And then we need to divide by the tangent of 54. Both sides. So b is actually going to be 5 over the tangent of 54. Now notice that if you go back to the original problem, the b and the tangent of 54 just kind of swapped places. So if you can recognize that, you can use that little shortcut going forward. So we need to use our calculator to figure out what 5 over the tangent of 54 is. And that is going to be 3.63. So the b is 3.63. All right, that just gives us b. So now we need to find the area of this particular triangle. So the area of this triangle is going to be base, which we just found, which is 3.63, times height, which we already knew is 5, divided by 2. So once again, we're going to use our calculator and figure out what that is. So if we type in 3.63 times 5 divided by 2, we end up getting 9.08. And that is the area of that particular triangle. So the area is 9.08. Now remember, we have a right and a left-hand side. So we have to multiply that by 2. So we're going to say the area of the right plus the left is going to end up being 9.08 times 2, so that's going to be 18.16. So 18.16 is going to be the area of the right and left. We've got the back, and now we need the bottom. All right, so the bottom is going to be also another rectangle. And so the bottom is just going to be length times width. Well, that's just going to be 12 times 3.63. So let's see what we get when we type that in. So 3.63 times 12 gives us 43.56. So the area of the bottom is just going to be 43.56. Okay, and the only other thing that we need now is the area of the rectangular panel. So that's going to be the front. All right, so in order to get the front, notice that we need to get the hypotenuse of the triangle that we were working with earlier. So let's see if we can do that. All right. I'm going to use sine. So I'm going to say sine of 54 is equal to the opposite side, which is 5, over the hypotenuse, which we'll call C. Doesn't really matter what letter. So C is going to equal 5 over the sine of 54. And let's see what that gives us. Actually gives us 6.18. So if we want to get the area of the front, that's just going to be 12 times 6.18. And that ends up giving us 74.16. So we'll say the area of the front is 74.16. Now, total surface area is adding up the back, the right, the left, the bottom, and the front. And when we do that, let's see what we get. We get, as a final answer, somewhere pretty close to 195.88. And that's in square feet, because this is in area. All right? So, to watch the video, and tomorrow in class we'll practice the homework problems.